Hi, I'm Mr. Evans, and today we're going to work on taking our net force that we've been working on and using it to actually get to kinetic energy, and we'll actually work backwards where if I give you kinetic energy, you can solve for the initial force that was applied. The goal is obviously to get to a point where I can be drawing diagrams and give you some pretty complex scenarios and even scenarios in two directions. But for the sake of space and just to get you going and giving some examples, we're just going to do some simple box problems. And so if I have my force diagram, and let's say this is a 40 kilogram object. Okay, so knowing that it's a 40 kilogram object, I can, and you should be able to solve for those up and down arrows, assuming it's moving left to right. And so this becomes 392.4 newtons, and this is 392.4 newtons. Again, if you don't know how to do that, all I did was use the W equals mg equation, and if you need a refresher on that, I know there's prior videos that work on that. From there, let's say this is 100 newtons and it experiences 20 newtons of friction. Okay, and so there is our object. And, if this box is on the ground, or basically on the ground, what I'm saying is I'm pushing it with 100 newtons of force and it's experiencing 20 newtons of friction. And so the net force I am giving the object is 80 newtons to the right. So with that information, I can now solve for its acceleration. So I do F equals ma, force is 80, mass is 40, and I can solve for a. And so the acceleration of my object is 2 meters a second squared. So now, if I want you to get to kinetic energy, I have to give you one more piece of information, which is time. How much time was that force applied? And so in this scenario, let's say it was applied for 5 seconds. So I'm telling you that for 5 seconds, I pushed on this box with 100 newtons of force, and during that time, it experienced 20 newtons of friction. And so with that being the case, I can do, velocity equals time times acceleration. And so the velocity of my object after 5 seconds, if it speeds up 2 meters per second every second, is 10 meters a second. So hopefully you're already seeing where to go next. I have now, solved for velocity. Oops. And I already still have the mass of the object, and those are what I need to solve for kinetic energy, right? 1/2 mass velocity squared. So I have 1/2 mass velocity squared. And so if I simplify that, I have 20 times 100. And so my final kinetic energy is 2,000 joules. Okay, and so you can relatively simply, at least in this scenario, go from a net force diagram to kinetic energy. So with that in mind, we can actually solve for something in the other direction. And so let's say I give you an object that has a mass of 10 kilograms and has 2,205 joules of kinetic energy. So I think these ones are slightly harder just because I think it's not as clear cut on the directions to take. So the first thing I'm going to do is solve for my unknown using the kinetic energy equation. And so if I say kinetic energy equals 1/2 times mass times velocity squared, my kinetic energy is 2,205 equals 1/2 mass, which is 10 times v squared. And keep in mind in this scenario, I would have to say this is after 3 seconds. So, using this information, I can solve for v, and v in this scenario equals 21 meters a second. So that's my velocity. The issue is that still doesn't give me the net force. So with velocity, if I know this velocity occurred after 3 seconds, and we're assuming constant acceleration, and although I didn't say that in the question, I easily could have, or if the scenario is going from energy to force or from force to energy, you have to assume a constant acceleration unless you really want a mind-blowing and complex question. And so with that being the case, all I have to do is divide this by 3. So all I did was drag time and take the time that's up here and move it down here. So I get 21 divided by 3, and so the acceleration was 7 meters a second squared. So now with mass, that I already have from before, and acceleration, I can use my F equals ma, with mass being 10, acceleration equals 7, and so my net force is 70. And so I didn't put a direction or anything on this, but at this point you could draw a box, and let's say that net force is supposed to be 70. There's your force diagram. Now, of course, I would like to eventually do more complex questions or more realistic ones, and so maybe I would say it was experiencing, 30 newtons of friction, and obviously the mass is 10 kilograms from before, and so you can solve for the up and down arrow. And so since it's experiencing 30 newtons of force to the right, the net force is 70. This force would have to be 100 newtons to cancel out that 30 to get a net force of 70. So again, the whole goal of this video was simply to introduce how to get from force to energy or from energy to force. And, with this information, I think you should hopefully be able to apply it to more complex scenarios. It'll obviously be harder, but, the ideas and the process is still the same. With that in mind, the next video, which is the last video of our force unit, will be putting it all together in the sense of, how could we get from force applied to the height of an object, which would apply, going from force to kinetic energy to potential energy to height. And so that will be covered in our last video.